Okay, let's have a look at GNS3, and IPv6 Demo is a good name for that. It's an empty project, so let's add some routers. Could add a 2600 router, but we're not. We're going to use some 3725, so we're going to have two of those, router 1 and router 2. So let's put router 1 on first, and then router 2, same image. I'm adding here a VirtualBox host. We could use that to reinforce what's going on IPv6 style between router 1 and our host, in this case, which is using XP and enabling v6. I've actually enabled v6 and disabled v4, which is very much taken away from its default sort of behavior. Router 1 connected via fast Ethernet port 00 to router 2, and we could use the spare port to connect down to the v6 node, the XP node that is, of course. For the sharp-eyed, we'd see that's connected to Ethernet 0. Don't worry about that. There's no real difference in speed because it's a virtualized environment controlled by GNS3. So I've just started router 1, so we can see the red interfaces have gone green, and we'll do the same with router 2. So they are now available in GNS3. They're up and running. No configuration on them as yet, though. Putting Wireshark on, doesn't matter which end, running that between router 1 and router 2, nothing there as expected. So no traffic because we haven't enabled any interfaces as yet. So we need to go in as though we're plugged in on the console lead. So we're going to go in on router 1, right click and down to console, and let's see what IPv6 things are happening as we speak. So a show IPv6 route, nothing in the routing table except the header information, the codes you get on the output. So that's blankety blank as expected. We haven't put any routing information in here as yet. We haven't enabled anything for IPv6 yet. Okay, just reinforce that. Are there any IPv6 addresses on here? There shouldn't be. So look at the interfaces using show IPv6 interface brief, using the abbreviated version of interface, of course. Two interfaces, no IP addresses, and they are down as we speak. They've been shut down. So we need to enable those. So first things first, we need to enable IPv6 globally. So global configuration and IPv6 unicast routing. We need to do that on each of the routers as we go through any of our IPv6 networks, but we're just going to do that on router 1 at the moment. We'll go down onto interface fast Ethernet 00 because that's the connection between router 1 and router 2. We enable IPv6 first using IPv6 enable. Now we can start really getting to grips with it. Let's put an address on it. Now the ways you can put the address on here could be the whole address, it could be just the prefix, and then we'll let it automatically generate the remainder of the address, the interface portion of the address, or we could go into auto configure. Now for auto configure we need another router that's advertising the prefixes that they can use to create their IPv6 addresses. Now currently there isn't any because it's the first router, so we won't use the auto configure option. So what we're doing here is we're putting in a very simple prefix of BBBB :1//64, so that reinforces it's just the prefix portion, and we're using EUI64 to generate the rest of the address. No shut brings the interface up, and that should start some activity in Wireshark. There we go, looking at Wireshark we can see there's some ICMPv6 messages, and these are the messages that are being generated in terms of solicitation messages. So we're soliciting to see if an address exists out there, using the solicited no multicast address as part of that. We've also got neighbour advertisements going on and perhaps some router advertisements. Well, this is a router, so there should be some router advertisements. Looking inside one of those router advertisements, we could see that, of course, there's some IPv6 activity going out to the solicited no multicast address, as we can see, over the FF02 and so on. And then we can see that it's sending out for a target address of FE80. Well, that's the link local address. That's the very first time it would actually do that. It would actually go out and solicit for its link local address, and then come back later if it's got a unicast address and solicit for that as well. We can see there's a variety of messages going out here. All ICMPv6 perhaps. Well, we can filter for that, and we get a nice cleaner looking sort of screen. So we can see there's a variety of messages here. There's not just the neighbour solicitation, neighbour advertisements, which we can see, and they're going out sort of as we can see as they need to solicit for addresses, as they need to advertise those addresses. See, the contents of those addresses are different. You've got the link local address to start with, and then later on you've got the unicast addresses being tested for. That's duplicate address detection really in play. But we can also see, because it is a router, it will actually actively engage in router advertisements as well, and they'll be periodically sending those out so that other devices can actually see the prefixes they're advertising and perhaps then auto-configure from those addresses. Well, let's have a look at the interfaces before we go on. Do show IP interface brief. Of course, reveals nothing because that's the IPv4 side of life. So if we repeat that but put the v6 in there, we'll see the addresses associated with fast Ethernet 00, the link local address, the FE80, and the unicast address that started with the prefix that we set, BBBB, :1, : and then the rest of the address, the interface portion of this, has been generated as an EUI64 address. You can see that because right smack bang in the middle of the interface portion of the address is FFFE, which is inserted into the MAC address to take it up from 48 bits to 64 bits. We flip bit 6 and that generates a complete EUI64 address. So, router 1 has got some activity. We can see that in the Wireshark trace, all of the activities from router 1. It's time to start router 2. So moving across to the console on router 2, straight into global configuration. Need to start IPv6 globally and then straight into the interface, which of course again is fast Ethernet 00. Start off by enabling IPv6 and let's set an IPv6 address. But let's use the auto configure option, because we've already got a router advertising prefixes. So if we use the auto configure option, then what it should do is take the prefix, add on its interface portion, and that would generate the IPv6 address. So if we look at the IPv6 interfaces, we can see that fast Ethernet 00 is up with a link local address. It's up with a global unicast address with the same prefix as router 1. It's got a different interface portion, which is reflected on both the link local and the unicast address, and if you look at those, they are the same because it's generated it from the MAC address associated with its own interface, converted it into a EUI64 address, and Bob's your uncle, we've got a unique address operating down here on router 2. Router 1, router 2 quite happily now engaging and exchanging IPv6 packets, which we can see on Wireshark. So we should see activity that's coming from both sides. We can investigate then the sorts of messages that we'd like to see, which is the solicitation messages, the advertisement messages as part of duplicate address detection, and then the route of advertisements, which would be normally engaged with any router that's out there. So again, here's the Wireshark stuff. More activity now coming in, as we'll now start to see activity coming in from both routers. Obviously they share the same prefix, but what we should start to see down there is we should also start to see different link local addresses being used as well. So Wireshark, very, very useful tool. Can investigate, dig deep down into the packets, just like using Windows Explorer. Once you select a packet, you can open those up, those various layers. You can see inside the IPv6 part, so the addressing part in the main. You can also see within the actual contents of the messages as well. So hopefully that's been a useful introduction into some aspects of IPv6, and we look forward to seeing you with some other videos a little bit later on.